Cameron White. Keep going. Cameron White, this is my informative speech. Alright, so good morning everybody. Today we're going to talk about GTAW, which is gas tungsten arc welding. We're going to talk about the history of it. We're going to talk about the modern uses and why it's used today versus other types of welding. So, quick rundown of the history of it. It was patented in 1890. I'm not exactly sure by who. I couldn't figure out who patented the idea of TIG welding. But in 1940, right around the time of World War II, we started using different types of metals. We started using alloys, we started using magnesium-based welding materials, and other sorts of metal. So, at the time we had stick welding, MIG welding was kind of becoming a thing, and then we needed something new. So that's where TIG, which is TIG inert gas, or GTAW, gas tungsten arc welding again, came into play. A man by the name of Russell Meredith invented it. He made it physical. And what he used it on was like alloys for planes, such as like titanium, aluminum, things of that nature. So modern uses, you have AC welding machines, which are for using aluminum. They use alternating current, which most of you know. And then you have DC electronegative, which is direct current electronegative welding capabilities out of machines like this. When you're working huge shutdowns and things of that nature, you'll see these in big stacks, and that's what they mostly use to TIG weld. So, the modern uses and why we use TIG welding is that it is a very clean process. TIG welding does not produce spatter. It's very controllable, and for an experienced welder, it's easy to manipulate the puddle, have positive penetration, and lots of other things. So how you TIG weld is, instead of using a consumable inside your rig, you use a tungsten electrode, which is reused, and then you use filler metal, combined metal. Now, one thing about TIG is that TIG does not consume tungsten, right? So, TIG puts most of the heat inside of the base metal. So you have a 70 to 30 ratio in most welding processes. 70% goes inside your electrode and 30% of the heat goes inside your base metal. Well, in TIG, you use 70% heat inside the tungsten, which is made at a high enough consumption rate that it doesn't burn it up, and then you put more of the heat in the base metal. So you have a 30% mix in your torch, and then in your base metal and your filler metal that you will feed with your left or right hand, depending on what hand you're dominant with, you put more of the heat. This causes better fusion. It causes, it makes it less likely to have a problem of like lack of fusion. There's no slag, so you have no slag inclusions or anything of that nature. So another thing is, when you're in flammable areas, like in some plants, you'll be around chemicals, flammable materials, things of that nature. So when you get around flammable materials, you don't want to have a lot of sparks like you would from stick welding, MIG welding, things of that nature. So we use TIG. Now TIG has several different mixes of gas depending on what you're running, how hot you want to run. You have 100% argon, you have helium, and there's one other one that I'm not quite sure about. So, sir? Stargon. So helium makes your weld hotter. So when you're wanting to burn hotter, you have thicker material, you use helium. When you're using everyday things like Schedule 40 pipe, like we use in here every day, A36 carbon steel, you're going to use 100% argon. Now tungsten, there's a lot of types of tungsten. You have 2% thoriated. You have all different types. Your most common type you're going to use is 2% thoriated. It's tungsten with the red tip on the end. So again, to reiterate, it was created by Russell Meredith, used on World War II aircraft and alloys. It was used, it's used today in plant shutdowns to prevent a lot of mess and a lot of cleanup. You have DC electronegative machines, and then you have alternating current machines. These are for your alloys. This is for your carbon steels, stainless steels, non-chrome, chromium, all of that type of material. Most of my resources I used for this speech came from Prime Weld and Sexind, or Section.com, SETXIND. And then it also came from our level 2 book and our level 3 book out of NCCER. Thank you for your time.